What is up, ladies and gentlemen? Welcome to day 47 of OnShape. Today what we're going to be doing is we're going to be taking our bolt that we made on day 15 and we're going to be making a nut that accompanies it. The threads match perfectly. And then on top of that, we're going to throw in the animation constraint that we need to where our nut will rotate around our bolt correctly. Okay, if you haven't already done so and followed along with day 15 making the bolt, go ahead and watch the video here. And that video will then help you make the bolt. Now we're just going to make the nut. So if you're following along with me, you should be right here, ready to roll. Okay, the first thing I'm going to do is I'm going to click on Sketch. And I am going to click on a sketch plane where my nut is able to go through. And so I'm just going to do the edge of the bolt here. There's kind of a couple different ways you can do it. Do it however you want, or you can just follow with me 100%. So I want to make our body of the nut. And I'm going to reuse some geometry we've already done. So I'm going to click on Project here. What Project does is it'll allow me to take some geometry, 2D geometry, and pull it into that sketch. So what we're doing is I've pulled in this hexagonal piece here into my sketch and I can reuse it. All the dimensions are exactly the same. You notice when I pull it in, it is solid black, meaning it is fully constrained. Okay, so we go ahead and click check mark. We're looking good. All I need to do now is extrude that part. So I'm going to click on, or hit Shift E for extrude, and we're then going to click on Sketch 6. The depth of our nut is going to be 1/2 inch. And that's it. We're done. Not really. Okay. We are going to make this anew since the nut is separate from the bolt. And we want those to be 2 separate parts. So now that we have 2 separate parts, let's go ahead and name them. Let's name this bolt. And let's name this the nut. All right. Now what I'm going to do is we're going to introduce a new operation called Boolean. But before we do that, we need to have these parts overlapping in the way we want them to. And so my nut here needs to be transformed. So I click on the transform button. Looks like a box rotating. We're going to click on our nut to rotate, or sorry, to translate. And we're going to translate it in XYZ direction, meaning I can drag it in any direction I want to. And what I'm going to do is I'm just going to drag it up that bolt stem to where it's completely on the bolt. Hit the green check mark, and there we go. Some people say, hey, it looks like we're done. Not quite, because if I take the bolt away, my nut body is still full. So how do we take that part out of there? And that's that Boolean operation. So if I click on here, Boolean, it looks like a Venn diagram. We have 3 different options. Now, Boolean is a mathematical operation specifically dealing with functions, but we're going to use it to deal with 3D geometries, which in some, I guess, way to say they are also functions. We are going to do a Boolean operation. I'm just going to show all 3 real quickly. So union allows you to take 2 different parts, and as long as they're touching, you can make them one part. So the tools we're going to use for our Boolean are going to be the bolt and the nut, and it's going to just make them one part. That's not quite what we need. What we can do is also look at intersect, and it'll say is where are those 2 pieces intersecting at, and that's going to be what's left over. And these pieces are intersecting with just those threads. Well, that's not what we want. Instead, what we're going to do subtract. And instead of our tools, we need to choose a target. So our tools, we're going to use the bolt to target or to take out of the nut body. Okay. Now, I haven't clicked anything else yet, but you notice that my bolt is now grayed out. It is going to consume it and use it. And if we don't like it, it's going to disappear. And we don't like that. So what we're going to do then is we're actually going to keep tools. And so by clicking on keeping tools, it will bore out those inside threads, but keep my bolt still alive and well. Okay? All we need to do is go to our assembly and put our constraints. So let's try this out. So I'm going to click on plus sign, create assembly, and we're going to insert that Part Studio we just made. Okay, we're looking good. Hit the green check mark. Now, if I were to say, hey, I'm done, but, you know, I can move my pieces still. Not quite. What we're going to do first is we're going to take our bolt, and we don't want it to move. So we're going to right-click on it and hit Fix. So now my bolt will not move. We're done. Not quite. All right, instead, we're going to do a cylindrical mate. So a cylindrical mate will do two actions at the same time. It'll rotate around one axis and slide down another. So what we're going to do is we're going to click on cylindrical mate, and we're going to have it go about this axis and through this face. Okay. Click play, and does it work in the way I expect it to? Absolutely. You know, almost didn't need to fix anything else. We can fix our limits here, and so we can say, you know, our minimum is going to be 0 because we don't going, you know, how about we have let's have negative point, you know, negative ½ inch. And our maximum to be, you know, let's do 1.5. I think that's the length of my bolt. It might be too long. Oh, there we go. You know, I want the bolt to come completely off, and I want the nut to go completely back on. Okay, the only problem is that with this cylindrical constraint, it is free to spin and slide. And so those threads don't actually interact with each other in the way we'd want them to. So instead, what we do then is we throw in a screw relationship. So you can't go straight to the screw relationship, or at least not the way I found. You have to throw in a cylindrical constraint first. And so what it is that there are certain types of constraints that are focused or types of other mates. And so what we're going to do then is we're going to take this cylindrical mate we just made and turn it into a screw mate. Now, distance per revolution. Well, I know I have 20 threads per inch, so 1 revolution should be 1/20th of an inch. So if you put your distance in here per revolution, or you could say in, you know, the inverse of your thread count, we hit the check mark, and we're looking good. So now, if I spin this once, our threads are actually going in the direction we want them to, at the rate we expect them to, and they're interlocked. So if I go up or down or left or right, there we go. Let's see if I can do it this way. There we go. Righty-tighty, lefty-loosey, and look, our nut and bolt works wonders. We are going to have a couple students try to 3D print these parts, see if they work. If so, check out on social media. I'm going to post some of those. What are the limits of what we can do? We're going to try maybe 10 threads per inch and then up to 20 threads per inch to see what kind of nuts and bolts we can actually print out. Well, ladies and gentlemen, there you go. We have officially made a bolt with an accompanying nut. And the way we've done this is that if we were to make any changes to the threads, the nut would automatically change since it's a design that is following the constraints of what we said with those Boolean operations. This is a really fun part to make because with this, we're going to start to get in the realm of machinery. And so we're going to look at rack and pinion and some gear systems and hopefully some really cool stuff down the road. I'm looking to make good content rather than fast content, so just sit tight if you're waiting for the next video, or if you got an awesome idea, feel free to shoot out to me in any way. It could be in the comments, could be social media, you know, whatever way you feel comfortable in reaching out. I'd love to hear your ideas of what you'd like to see. Well, guys, that's all I got for today. Feel free to share, like, and subscribe. Please, if these videos have been helpful, I would love to hear that. It is nothing but awesome to hear how these videos have been helpful for other teachers, other students, and just people who are tinkering around with some 3D printers. Okay, guys, I will catch you guys in the next video. Until then, take care.